Okay, so let's talk about the project. So the first page in front of you is okay, I'm gonna have to do it from here. So you have this. It says parabolas everywhere. Once you start looking, please stop talking. Zoe, will you turn the light off for me? It says once you start looking for parabolas, you will be amazed with how many you can find. Here are just a few examples of where you might see them. So you have the purple paper in front of you right now. This is what we're looking at. It says architects and engineers use parabola in the designs of bridges and buildings. Since a flying object freely flows through the air, follows the path of parabola, video game programmers use them as models to make motion appear realistic. Parabolas can be seen in the path of water flows as it's shot from a water fountain. And then also parabolas in nature as well, like sometimes in the shapes of leaves or petals, things like that, right? Okay, so it says, getting started. Find 3 pictures with real-world examples of parabolas. 1 picture with 1 parabola, that can be from the internet. 1 picture with 2 or more parabolas can be from the internet. And then 1 picture has to have at least 1 parabola taken by you. Okay, so find a picture somewhere. It says, describe each picture stating its source, location. Use transformations to overlay a graph in GeoGebra. Write equations for each parabola in all 3 forms, vertex, standard form, and factored form. State the parts of the parabola. And then it says extra credit of 7 points will be added if you do all of the following to 1 extra parabola picture. So you have to do 3 different pictures. If you want to do a 4th picture, that gives you the opportunity to make over 100. So if you're not happy with your average right now, this is where it's at, this project, right? So it's a test grade. It needs to be done by the end of class on Thursday, and we will present them on Friday. You can work with a partner, but you need to choose wisely. I highly suggest you work with a partner in case something happens, you get sick, whatever, and you can't be here. That way you guys can help each other pick up the slack. So, but like I said, choose wisely. All right, this is the rubric in front of you on the yellow page. Okay, guys, nothing of this is my discretion. None of this is my opinion. This you either do this or you don't to get the points, right? Okay, so you've got the parabola with the on the picture. You've got equations in all forms correctly. You've got description of the parabola. For example, on my look at this one example that I have. It's got a picture of a lamp in my house. Looks like that, right? My description says, I mean, it's super complicated, let me tell you. It says, this is a picture of the lamp in my house. It is tall and has a parabola-shaped hook that holds the lampshade. I use it to read and to make sure I don't trip over any toys in the living room when it's dark. Okay, so a little description, right? And then I've got my 3 different forms, and I've got the vertex and everything listed there, okay? Then it says all the parts, domain and range. Clearly explain the parts of the parabola in the presentation. So when you do your presentation on Friday, I'm just going to have you, this paper that you turn into me, we'll put it under the Elmo. You'll say, oh, this is a picture of yada, yada, yada. This is the equation we got, blah, blah, blah. Then the next one, this is a picture of yada, yada, yada. This is the equation we got, blah, 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 right? Your presentation is very short and sweet. Shouldn't take, not a lot of things going on there, okay? And you don't have to prepare anything extra other than what the actual project is, okay? So you've got certain total points possible on each of the pictures, right? And then, so your total points possible is 132 points. So what that means is, when you go to figure your grade, you have to do it out of 132, okay? So, if I was going to figure out the grade, so here are some examples, like if you got 100 points out of 32, that's a 76, right? If you get all your points plus the 7, like the extra credit 7, you could get 105, right? So when you're figuring out your grade and your points, you would have to do it like this. It's a percentage out of the 132 points. Okay, so you should know what your grade's going to be before you ever even turn it in to me. You should be looking at that rubric the whole time you're going through your project, making sure you're getting all of those points, right? There should be tons and tons of hundreds, okay? All right, so let's see.
I was getting excited. I thought I was supposed to get 132.
Oh, no, sorry. Okay, says, so here's this paper. This is the white packet I gave you. The white packet that I gave you is what you actually turn in. Obviously, you would just turn in one copy per partner, but I gave you both a copy in case you messed something up. So it says, this, along with the rubric, is what you turn in to me. Do not write on this until you are sure the answers are correct, okay? So do stuff on scratch paper before you start writing on this. I'm not going to give you a ton of copies.
And then we put our picture down here. We glue it on there.
Just like I have on mine. Okay, this is your final copy, right?
What are you doing for the online part?
Okay, huh?
The online part.
The online part is where you find your picture.
That's it.
Yeah.
That's all we're doing online.
Yes. The rest of it is a program. All right. So, okay, I don't think my computer's working for me to write up here. It seems to know it's there, but it's not showing up. For some reason, All right, so I'm just going to have to tell you what to write here. Are you ready? So it says right-click on your picture. So, guys, most of this stuff I think you'll be able to figure out on your own. I was able to figure it out. So the only thing is some of the things about Mac that might be different than what you're used to. When you does anybody know how you right-click on a Mac?
Don't you put 2 fingers in?
2 fingers, click. So these Macs are newer than the white ones, so you don't actually have a click bar on this one. The whole mouse pad clicks. So you'll push down with 2 fingers and it right clicks. So when you right click, so I need you to write down what I'm saying out loud because I can't write it up here. You're going to write, maybe I can type it. So you'll click copy image. Okay, and then you open GeoGebra, which I'll show you what that looks like. And in GeoGebra, you'll click on the Edit menu, and you will choose Insert Image From. Okay, and you can either choose to insert it from the clipboard, or if you want to save it to the desktop. So when you find a picture on the internet and you're not sure, so you might find one that you like, you're like, oh, I'm not sure if that's what I want, and you just want to right click and save it to the desktop, that's no big deal. You just need to make sure once you pick the one you want that you erase the others from the desktop by dragging it into the trash can. So don't leave a bunch of junk on the desktop because everybody's going to be using these each class period. So if you want to save a couple pictures before you decide, that's fine. So if you have a saved image, you'll have to click on that. And then you can make the image larger or smaller by dragging the points on the image. Okay? All of these things I think are things you would figure out probably without me telling you, okay? All right, so then it says how to plot a quadratic function in the form. This is vertex form, right? So it says type your function at the bottom of the page in the input box. You have to use the little caret key 2 for the exponent on that one. And to edit the equation, you're going to click on input down at the bottom. And you'll scroll up. You can, the thing about this program is it saves everything that you type in. So if you just have to change one little thing, all you have to do is arrow up and change that one little piece of the equation. You don't have to retype the whole equation. So that's kind of nice. And it says you may need to delete You may need to delete functions listed on the left of the screen as it saves all the functions you enter. And then when you're done, you found, you got your picture in there, you found the parabola that perfectly matches it, and you're good with the line or the parabola that you have. You can change the color, the thickness, and some other properties of the parabola by right-clicking on the equation on the left side of the page, or you can right-click on the parabola itself and you choose Object Properties. Okay. Once the pick is where you want it and not before, guys, because once you do this, you can't undo it. All right. So once the pick is where you want it and not before, you right-click with 2 fingers on the mouse pad on the image, and you choose again Object Properties, and then click on the Basic tab. And then you do the little check mark where it says background image. So what that does is it allows you to actually see all the X and the Y axis. So you want the picture to be in the background, right? So you can see the axis clearly. So when you think that you are done with your picture, with your equation and everything, you need to call me over and say, okay, how does this look? That way I can notice little things like, oh, you forgot to do background image, or oh, let's make this line a little bit thicker, and let's change the color to green, or something where it'll stand out better, stuff like that, okay? So make sure you call me over when you think that you've finished one of your pictures, all right? Also, once you've got the right equation, you can go to the Object Properties and click Show Label, and you want it to say value on that thing. So that way it'll have the equation there. So those are things that I'll notice. So you need to make sure you are you're calling me over for those things, okay? Alright, so last little bit here. Saving as a GeoGebra file. So you click Save As, and you want to make sure you title it with your name. Okay, with your name and the picture number. Okay, a couple different places you can save it. You could save it in the public drive. I created a folder in the CHS public drive that says Weed, Algebra 2, and then your class period folder will be in there, so you can save it there. Or you can bring a flash drive to save it to, or you can save it to the desktop and just email it to yourself. But guys, after you do that, you don't want to leave it. I think it's a bad idea to save it to the desktop and leave it there because you don't want somebody else trying to use your picture. And then I'm going, hey, why do the two of you have the exact same picture here? You know what I mean? Who's copying who kind of thing. So be careful with that. And then make sure you delete it from the desktop when you're done. After saving, in order to print these pictures, if you don't print it from a computer that has GeoGebra, which I don't know of any computer that would have GeoGebra, like downstairs in the library, it's not going to have that. So you need to make sure you export it as a graphics file so that you can pull it up on a different computer to print it, okay? So when you're done and you save it, then you're going to export it, and you can, put it on the public drive and go downstairs to the library and print it out, or you can email it to yourself as the graphics and the graphic file and print it out at home. Okay, but either way, you're going to have to export it because you can't print from these computers here in the classroom. Okay, so it says if you're printing from a computer that does not have GeoGebra, then you'll need to export it by doing the following steps. So click File, Export. Okay, to graphics view, and it says PNG, which I was able to open just fine, so hopefully that'll open on any computer. If it won't open on your computer at home, we'll just have to try exporting it to a different file. Okay, and then it says you can email it to yourself to print at home, or go to the library to retrieve it from the public drive and print there. The library charges 10 cents for black and white and 25 cents for color. I would prefer color so we can see the parabola clearly. So guys, the most you would have to spend, you've got your 3 pictures that you have to have, and a possible 4th for extra credit would be $1. Okay, And so 50 cents for each of you, okay, if you're with your partner. So that's it. You shouldn't be spending a lot of money printing these things out. 50 cents is too much for you? Maybe I'll let you borrow something. All right, so now turn your pink page over so that you can make notes on it as I show you a GeoGebra thing. So down here, you see this little guy right here? That's the GeoGebra icon. If you can't find it, you just go up here and type in GeoGebra, okay, and hit enter. Okay, and then this guy, this will start opening up. Okay, so you're going to want to go and search on the internet for a picture, unless you have pictures of your own. So I just put in parabolas in nature. You could put parabolas in architecture. You could just put parabolas in real life and go to the images tab. And of course, it's going to take forever because I'm recording. Okay, I like this one. So there's tons of things to choose from, but I like this one. So I click on View Image, so I've got a good picture of it. Okay, clear. I guess that's not going to work for me. So I'll just right-click it and say Copy Image. And then I go to my GeoGebra. And I go up here, so it says GeoGebra, and I say Edit. Insert image from clipboard. And that guy pops up. Now, notice this parabola is not facing the right direction, right? It needs to either be straight up and down. So you take these little points and you can tilt it, make it bigger or smaller, however you want it to look. Okay, but you want to try to make it as straight up and down as possible. But these wings make a parabola shape, right? Okay. And so then I go down here and I start trying out some equations. So, and I would write this down, but the first thing I would do is just try to do your vertex. I wouldn't start messing with the A until you get some vertex in. So you're going to do this in vertex form. So you might want to write that down on the back of your pink page to write in vertex form. So down here at the bottom, I type in y equals. So it looks like maybe we went right about, I don't know, 5, and then up maybe about 5. So let's try that and see. So I'm going to type in at the bottom, x minus 5, caret squared, and then plus 5. Okay, now it's opening down, so what does that mean? What do I need in front if it's opening down? Negative. Okay, so I press enter, and that's what comes up. Okay, see that parabola there? And so there's my equation also in standard form up here. All right? Can everybody see that okay? Okay, so obviously I need to go a little bit further down and to the right a little bit more. So I'm just going to arrow up on my input line and change this to, let's change it to, what did I put before? I put 5 before, so let's change it to 6. And let's go down just a little bit to 4. Let's see. Oh, man, pretty good. I might need to go just a little bit more to the right. So maybe 6.2. Okay, so I'm going to delete these other guys out of here because I think that's maybe too far to the right. I'm going to go with 6.1. So delete the ones that you don't want out of there. Okay, again, that's too far to the right. I need to even go even smaller. I'm going to go to 5.9. No, maybe I should stay with 6. So you get the idea. You have to kind of mess with it a little bit till you get what you want. And delete out the ones that you don't want. Okay, then after I get it about where the vertex is, I start playing with the A. So if I want it to be a little bit fatter, I'm going to do something like 0.5 or 0.2 or 0.32, something like that, right, to make it a little bit fatter. So 0.3 makes it look like that, so that's not quite small enough. So 0.2, it's a little bit better. That might be almost it. Okay, so I'd have to just mess with it a little bit. And once I found what fire, Control Z. Once I found what I wanted, okay, I think I might have to tilt my picture just a little bit more. Okay, and move it over just a tiny, So I had to move my picture just a little bit. Now, guys, remember, this is in nature, so it's not going to be a perfect parabola. So if you notice, the picture, let me change the color so you can see. Okay, it fits majority of the wings, but not exactly, right? So it should be really, really close, but it may not be perfect in nature. Now, if you're doing something with architecture, you should be a little bit better at it, okay? It should be able to fit a little bit better. You got to make sure that your picture is at the right angle. You can't take a picture of a parabola from underneath and think that it's going to match up on here. It needs to be, the picture has to be straight on, okay? So you have to make sure it's a good picture. Like I started out trying to do the Eiffel Tower, and the picture I got, it was kind of from underneath, the Eiffel Tower. It needed to be straight on. So if I really was dead set on doing the Eiffel Tower, I would have had to search for other images of it to make it work, okay? So anyways, that's what you're doing. So you've got down here you've got vertex form, right? And then up here they put it in standard form for you. So all you have to do is do intercept form, okay? So you're going to have to do intercept form on your own with the calculator, and you can use the trace button for that, all right? You kind of starting to get the idea of what you're doing tomorrow? All right. Okay, so it's almost time to go. No, I should have already gotten that back.